Hi, this is George McCartney for EL6453, and this is my AES Decryption and Encryption simulation video. So I'm connected to the Xilinx FPGA via universal asynchronous receiver-transmitter protocol with a serial interface. So I send serial commands via real term, and I first, via a state machine, if it receives a W, it's for write. If it receives an R, it's for read. And so the second character is the value, and the third character is the address for write, for the write command. If it's read, it just reads the address value that it specifies. So the first thing I'm going to do is reset my board via the input here. And then I'm going to, so it's initialized plain text to all zeros as well as the key as all zeros. And then I'm going to read out all the addresses to see what the ciphertext is. And I'm going to send this file via real term. So if I send the file here, I see it responds back with values DC95, C0, 7, 8, and so forth. And if you look here, the expected values are DC95, C0, 7, 8, and so forth. So that's just for if the key value is all 0 and the plain text is all 0. So if I change the key, to be 80, which is one of the test vectors for this project, for the test bench. You see it here. I'll specify that 80 in address 20, which specifies the first address of the key. So then I will clear my real term, and I will send this new command. Sorry, I need to change the file. So when I choose the file for the next encryption, and I send it, I see it returns back E35860CB and so forth. And if you see, if I have my key in hex is 8 and the rest all zeros, and my plain text all zeros, the expected ciphertext is also E35A60CB and so forth. Now realterm can only read 15 values at a time, so I need to read the last value out, and I'll show you here. If I send R180, it responds with value 59 in hex, which is the last value of the expected ciphertext. So on my digital board here, if I change my switch here to 0, then I'll reset. This initiates it as a 0, it initiates it into decryption mode. So if I go up to here and I see my new file for decryption, I'm going to write 80 to the 20th address, which is the first 2 bytes, or first byte for my key. So again, the key is now 8 in all zeros, and I have my expected ciphertext set to all zeros. So then when I write 1 to 4, it says key is valid, and then I write 1 to address 8, meaning that I should initialize my encryption or decryption, and it will decrypt now because my flag is set to 0 for decryption. And then it'll read out the values. So let me send that file via real term. And I'll clear my terminal. So I'll send this, and we'll see if I decrypt ciphertext of all zeros, I get back 14226E7B and so forth. And let me read the last value out of that register, and I see it's F2. So if I look at my decryption here for a key 8 in all zeros and an expected and the ciphertext of all zeros, my plain text back out is 1F226E7B and so forth. And that's the same I see up here. The 1F just gets cut off from the real term, so you see 6E, 7B, 32, 19, and so forth. So as you can see, the encryption and decryption algorithm works fine. You can also use some switches on the board to see the last address that you read out, which is address 180, and also the value in 180, which is F2. And if you look on RealTerm, the last value in register 80 is F2. So this is my simulation video, and I will submit my port later this evening. Thank you.